house robber 4. So we are given with a robber which robs houses which are represented with nums. So we are given with an array which is represented as nums. So these nums has how much money is stashed in each house. So ith house from the left has nums of I dollars. Now the thing is, the robber denies to rob from the adjacent houses. So imagine he robbed $2 from the zeroth index house. Then he will not rob from the house which is adjacent to 0, which is 1. So he will not rob that. Instead, he can rob 3 at second index, and also he can rob at third index. So he will not rob from the adjacent houses. Now we are given with 2. So robber can rob from at least two houses. From at least two. So even imagine we are given with the size is 3. So and the k is 2. That means he can rob from at least two houses. And at max he can rob as 3 houses, but it is not as important as k is equal to 2. We don't need how much at the max houses he can rob. We only need the minimum value or minimum houses the robber can rob. Now the actual problem is the capability of the robber is minimum amount of energy he steals from one house of all the houses he robbed. So if I break down this question simply, firstly, take these indices and what are all the combinations that the robber can rob from. The first combination here we are given with k is equal to 2. That means he can rob from at least two houses. Now I will take 2. I will take 2. And I cannot take 3, so I'll take 5. I'll take 5. Now, what is the maximum from these two? 5. Now, let me go and take another thing here. 3 and 9. Right? Here I can get 3 as my first house robbed, and 9 is the next house robbed because this is adjacent, so I cannot take that. 3, comma 9. They are asked with every combination we will have a maximum value. Every combination we will have a maximum value. And all the combinations, from all the combinations, I need the minimum value. So for this, the answer would be 5. But the problem is how can we get this 5? And how can we get this maximum and then the minimum value from all the combinations? So for this question, the k is given as 2. Now my intuition will be going through this question. Wait a second, it would be something like 1 here, right? Yes, here it is 1. Now k is given as 2. I need to get something where I will get all the houses robbed, and I'll get the minimum from the maximum values. So it is something like a question minimized maximum, as the question you can imagine like that. Now, first thing, what is the minimum houses that I can rob? That is 2. I can rob 2 houses, but what is, like, if I take all these combinations, let me start by taking all the combinations. Minimum I can take 2 houses. So first thing I'll take 2, and then I cannot take 7, so I'll take 9. And also first thing I'll write all the combinations of houses with k is equal to 2. That means only 2 houses. So 2 comma 9, and then 2 comma 2 comma 3, and then 2 comma 1. After that I'll take 7. So here 7, and then 7 comma 3, 7 comma 1. 7 I'll write here 7 comma 3 and 7 comma 1. Now after that I'll take 9. Now 9 comma 1 is the only combination. 9 comma 1 is the only combination. Then can I take 3? No. Why? If I take 3, then there is no second house. There is no second house. So if I take 3 or if I take 1, then I cannot get the next house. So one house is the only house I can I can get by taking 3 or 1. So I'll skip this part. Now from this every combination I need the max. But before that, what if I took 3 houses robbed? So if I took 3 houses robbed, the only combination is 2, 9 and 1, right? So let me write that 2 comma 9 comma 1. Now as I said, minimized maximum. So let us take the maximum from every time. So if I write the maximum here, it is 9, it is 3, it is 2 here, it is 7 here, it is 7 here, it is 9 here, and it is 9 here. From all these combinations, it is something like 2 is the minimum value. So here it is 2, but minimized maximum. But let us understand here 2 is my answer. Somehow I need to get this 2. I need to get to this 2, right? I need to get to this 2. Now I have all the values which are in my nums array, right? I have the minimum value which is 1. So I'll write that. I have the minimum value which is 1. 1 I can rob only, like 1 is the house I have robbed. Now after that I have 2 as the value, and also I have 3 as the value, and also I have 7 as the value, and also 9. What does this represent? This represent 1 is the minimum value that I can rob. That means imagine taking this one. So this would be the maximum from k combinations, at least k combinations. So take this 2. Now I have 1. That means 1 is the maximum from all the combinations. But why? Because this would be my answer. This would be my answer, right? So 1 is the maximum and below should be lesser, but there is nothing like that. So let me take 9. Now all the houses that can be robbed by taking 9 as the maximum value, or the answer is 7, 3, 2, and also 1. These are the houses which can be robbed by taking 9. So these all values, but if I take this by something like, here I have 2. So let me take this off. Here I have 2. So which is lesser than 9? As I said, I can take the houses which have dollars or money lesser than 9. Why? Because here if you see I have 9. Here if you see I have 9. So every time I get a 9, I need to, this is my answer, which is the maximum. So when I say maximum, all the below houses should be minimum. So 2 is lesser than 9, so I'll take it. Now 9 is also in the set, which is 9. So what is the count of houses that I robbed, which is 2? So 9 is a perfect thing that I can take. 9 is a perfect thing because it is having at least 2 houses to be robbed. So 9 is perfect. But what? Why I got 2? Because 2 is the minimum value. Minimum value. So instead of taking like, here I'll go, here I'll go, here I'll go, which will be taking much time, instead I'll take the maximum, the low value which is 1 and the high value which is 9, the minimum element and the maximum element from the nums, and the mid value will be considered by using a binary search. But there is a condition, right? Imagine I got to this 3, right? Just imagine I got to this 3. Now, how can I check this whether can I take this element or not? First thing I'll take this. First thing I'll take this. Why? Why I am taking the first element? Because 2 is lesser than 3. As I said, 3 is the maximum from all the values, all the answer values. I am taking 3. Now, the remaining combinations, remaining houses should have 2. So, 2 is the house. This is the house I am taking. I am considering 2 is lesser than 3. So, I am considering this. Now, if I consider 2, the previous value, the previous index is 0. Now, I get to 1. If I take the difference 1 minus 0, it is not greater than 1. So I'll skip this. What does that mean? It means the previous index where I get or where I robbed the house and the current index is 1. These two are adjacent, so I can't take it. So I'll go to the next index, which is 2. 2 minus 0 is greater than 1. Now, 9, can I take it? No, I cannot take because 9 is greater than 3. So I cannot take 9. So I'll skip this part and go to the next element, which is 3. Now 3 is lesser than or is equal to 3. So I can take this 3 and my previous will come here instead of change it to here, and my count initially I have took 2 as my house. So index 0, 2 is the number of dollars of money. So initially it would be 0 and then I took the 0th index house and it become 1, and then I increment it and it here I got 3, so it is 2. But still now the answer is not found. That means whenever the count of houses robbed, for that I'll write a get count function. Whenever the get count, which is greater than or is equal to k, greater than or is equal to k. So here I got k values, so it would be on the left side, which is minimum. So I will go left. Now, you might say, when I need to go right, here I have 1. Just imagine I have 1. So, these are all the values that I cannot take. 2 is greater than 1. I cannot, and I can take only 1. And the count is just 1. So, when get count, when get count is lesser than k, that means this value, this maximum value from all these combinations is not suitable or it is lesser. So I need to go to the right side. I need to go to the right side and take more value or greater value. So go right, go right. Now, as I said, the lowest value, I will write the algorithm simply here. I'll write the algorithm here. Now, the lowest value, as I said, the minimum value, and the highest value is the maximum value. Lowest value is the minimum, highest value is the maximum, and while low is lesser than high, I'll calculate mid. But at this point, I am calling for get count function. I also write this get count function, but before that, this binary search function will return lowest value. Now, here I have get count function. In this function, I will be having a mid value. Instead, I'll call it as maximum value. As I said, this would be the maximum value or the maximum dollars that I can store or that I can rob from a house. Maximum value, and I also pass with this nums. So this will return get count. Initially the count is set to 0 and the previous value is set to something like -2. For, as I said, here it is not something like I get the previous at 0th index itself. Here I got the previous after 3 indices. That means I need to search for the previous index where the current and the previous difference is greater than 1, and also the current house value is lesser than the maximum value. So for I is equal to 0 to n, I is equal to 0 to n. Now if I minus previous is greater than 1, previous is greater than 1, and I need to check for another thing. So if I minus previous is greater than 1 and another condition is it is lesser than the maximum value, lesser than or equal to, lesser than, sorry, maximum value should be greater than or equal to nums of I. Then what I will do at this point, I will initialize my previous to current index I as I said before, and I'll increment my count plus plus. So this is the if condition and this is the for loop, and at last I'll return my count. So this is how you solve this. This is quite simple if you have solved a question like this before. And let me go through the code. Here, as I said, get count will be initialized, previous is equal to -2 and count is 0. For I is equal to 0 to less than nums dot size, I minus previous should be greater than 1. That means these two houses should not be adjacent. Nums of I is less than or not equal to maximum value. So previous is initialized to current index I and count is incremented, and at last I will return my count. So low is the minimum element from nums and high is the maximum element from nums. While low is lesser than high, take the mid value, low plus high minus low by 2. House as robbed, get count of mid comma nums. Total houses robbed if it is greater than or equal to k, high is equal to mid. Else low is equal to mid plus 1, and I'll return low because I need the minimum value of these houses robbed. So minimum capability will be returned by a search of nums comma k. This is how you solve this problem. If you like this video, do share it to friends and do subscribe to my channel. Thank you.